Good evening. How's everybody? I'm Robert Schwenker. Welcome to Blockchain University Cohort 2 Demo Night here in Mountain View, California at TechCode. A warm welcome to all the new people here and all the old people here, the young people, the men, the women. And just to start off the evening, I thought we would have a photo, not of everybody, we'll do that maybe later. But
just 2 people.
Since there's been this rumor that Bitcoin is going to die because there's not enough women, I thought we should take a women's photo to prove that we'll keep blockchain alive. So all the ladies, please come up and we'll take a quick photo of all the women in the room, whoever identifies. Gender nude. Yeah, me too.
My wife's you. Oh, there she is. Oh, no, my wife doesn't like you to do video.
Yes. Oh, yes. Guests and otherwise. Suda Janki.
Wait, no comment.
Wait, so how are they
And
going to
Lillian will choreograph you with a little wave, maybe?
Oh, can you wait for a second for the video? So it's a little video that's going to be with blockchain. Hi, guys. Yes, there's girls in blockchain. Wait for a second. One hand wave and smile. 1 second. Okay, did you get it?
Did you get it?
And then let's smile for a photo. Okay. And what else? We should do a jump. It was so good.
And high heels?
So
Go
good.
for it.
Somebody else. We're good. Okay, girls. 1, 2, 3. Oh, you have to jump. You gotta squat a little. Ready for squat a little. 1, 2, 3.
Yay.
Okay,
Big
perfect.
hand to all the ladies.
Now you have to be back for the next group picture.
It'll be hard. Not quite. So, I'd like to bring up, I would like to recognize Larry and Sue of Zpark Capital. And Sue has a few words about this newly formed venture here, TechCode, which has come out of CFLD Capital. So I'll leave it up to Sue to tell us.
Thank you very much. I'm so happy to be one of the women here, and then really appreciate everyone to come today. And then I'm actually one of the partners at Zpark Capital, and then TechCode, a CFLD in China, which is a public company that you already know, was an LP for Zpark Capital. So that's why I'm actually the CEO now for TechCode, previously CFLD Capital. So Zpark Capital started about 4 years ago, and then we have first Chinese at Facebook, first Chinese at Google, and then we have VP at Yahoo, senior directors at Twitter and Uber, and all the some of the high tech companies in here, and we are all Chinese. And so I think the first fund, and we all geeks actually. So I think 80% of us have PhD, and so we're born to invest in early stage companies. And then so we're actually running Fund 2, which is about 15 million. And then some of our company already raising their Series B. So we actually started another fund, which is Fund 3, which is about 200 million. So Bitcoin is one of the, Bitcoin and blockchain technology is one of the area that we're really interested in. And in fact, Larry Lee here, he is the founding partner of Zpark Capital. He invested 2 companies, Skew and Quantify. So we're really happy that Skew and Quantify, the founders are also teaching together with a lot of the other experts. And then interestingly, once I actually started to be the CEO of TechCode, and then actually Larry helped to bring 7 Zpark Capital companies in this building, and we wanted to have like-minded people to actually host events here, exchange ideas and resources. And then one of the things for TechCode is that TechCode will have 50 tech code just like this, all around the world. So Tech Code Shanghai just opened about 1 month ago, and right now today, and Skew Chain founder Sharam, he is actually doing a information session about blockchain university in Shanghai Tech Code. So you will not just bringing tech code to be all around the world, but also we wanted to facilitate blockchain university to be global. So I will actually share some photos later on with Robert and every one of you about what's going on for Sharam to share about blockchain and Bitcoin in China. As a lot of you guys might have already known, in China, blockchain is almost, nobody is actually really studying blockchain. A lot of minors in China. So I think that will be phenomena if we can actually bring blockchain to China, and then you guys, if you guys wanted to actually establish presence in Shanghai or Beijing or some other cities in China, and please let us know. Okay, thank you so much, and I hope you guys have a very successful event. Thank you.
Thank you, Sue, CEO of Tech Code. So we actually have a Bitcoin mine here. It's underneath the building. In fact, if you take the elevator shaft down about 5 floors, you can see it. And if you don't find the button on the elevator out there in the lobby, you can stop by and see a few of our sponsors. So there's Thomas Francis from Ledger, hardware wallet in the back here. He's waving there. And thank you, Thomas. And then we have from BitPay, we have Eric Martindale, who will have a few words for us. So thank you very much, BitPay, for your great sponsorship from Cohort 1 and Cohort 2. Take it away, Eric.
Thanks, guys. So, Robert, as he said, my name is Eric Martindale. I'm the developer evangelist at BitPay. I have a former career in entrepreneurialism. I've been a founder and a CTO at my previous companies. But when I first started taking Bitcoin seriously in 2012, I thought it was just a currency, right? Like, that was really my first exposure to it. I was really excited for what it was going to do to the financial system, that it was really going to give us some liberty and freedom. One of the things that really struck me is as I've sort of grown in my understanding of what Bitcoin is and how it is just the first app on the blockchain, I've realized how impactful and exciting the blockchain actually is, right? This is, as much as I've seen, as much as many of us have seen, and I think you will all agree with me, this is the single most exciting, most revolutionary idea that has hit in the past probably 100 years, in my opinion, right? This is going to change everything. And you being here as part of this program, all of the things that each and one of you are building, all of the things that you're building with the tools that many of the companies here have helped build previously, you're building the future. And this is really exciting. And this is what BitPay truly believes in. We believe in open source. We believe that the only true secure software is open source software. And for that reason, we develop a number of open source products to help entrepreneurs and developers and designers build stuff like the things that you're going to see tonight. Some of those things are Bitcore, which is an open source JavaScript library, which just builds really nice abstractions for you, right? It'll really make it easy to interact with the same blockchain tech. The other is Copay, which is our open source, decentralized, multi-signature wallet, which you can use with Bitcore Wallet Service to host your own asynchronous transactions, proposals across multiple wallet participants. And for one, we're really excited to see what people have built and where the future is going. You being here in these seats tonight, it means you are some of the earliest adopters in the world in what will change every single industry on this planet. And for that, I want to give all of you a big round of applause for being here and thank you for all being a part of it.
Thank you, Eric, for a passionate speech. This is great. So there's been 2 cohorts. And how many people here are students or in one of the first or second cohort? So here's the student body so far. There were approximately 50 people in the first class, some 40 or so in the second class. The second class has been a 6-week course on Saturdays. We're going to have another cohort in San Francisco in June for 3 weekends at the offices of Price Waterhouse. So admissions and such are open for that, and I Also would like to acknowledge some very important people for the formation of this community and of all that we know as Blockchain University. And first of all, Lillian Chan, because of all the YouTube videos, everything, I thank you dearly, Lillian. Please applause for Lillian. She's just fantastic. Everything you've watched on videos for Cohort 1 and Cohort 2, now Jeff Flowers with his wife Elan Tang. Cohort 1. And thanks so much, Ryan Smith, tonight for live streaming us and recording for us tonight. And lastly, Joy Gui for really coordinating everything here at CFLD and Tech Code. Thank you, Joy. Next up, I'd like to bring Ranga Krishnan. Ranga Krishnan is part of our first cohort. And as part of the proof of what we're trying to do is get people who are looking for new jobs into new jobs. He was an early hire at Skew from Cohort 1. Incredible developer, incredible engineer. He's, I think, did some early studies in Madras and went on to do his PhD at MIT and postdoc work at Princeton, and he holds 30 patents. Anyway, I would like to bring him up to tell you some about Skew and their new Thing Chain technology, which some of the projects tonight you'll see are using. Ranga.
Thank you, Robert, for the very nice introduction. I'm the VP Engineering here at Skew and Robert thought it would be interesting to tell you a little bit about what we've been developing. So Skew was formed with the idea that there was a relationship between the double spend problem in Bitcoin and detection of counterfeit in the real world. And so the idea was, could there be, non-financial tech applications for blockchain technology? And this seemed like a promising one. And the relationship comes about this way. If you can get people in the supply chain at various points to take custody and record that custody down to the end consumer, then you can actually detect if fraudulent goods are introduced, because you can duplicate an identifier, but you cannot duplicate the history. There's a single history. And the key thing here is to have the end customer actually take custody. That's what makes the whole thing work. And getting that off the ground is not that easy. So when that's happening at a larger scale, I think it can have applications to many industries, such as pharmaceuticals, electronics, where there's a lot of need. To get the company bootstrapped, we kind of focused on sort of easier to approach industries, and those are, for example, food or wine. And as we were talking to people, we discovered there was interest in collectibles of various kinds, whether it's shoes or you're going to hear about one such application today from one of the student teams here. So the idea was, since we can't know what all these product spaces are, understand them, actually expose the technology as an API that people can build for their domain. And this underlying technology, we call it ThingChain. And so ThingChain has been launched, and you can go to thingchain.com, and you can actually, if you have an application in mind that you'd like to prototype, you can request an API key for us and develop your application. And one of the projects, as I mentioned, I'm not going to tell you more about it, actually uses exactly this to track the provenance of certain collectible items and make sure that things are not fraudulent. So ThingChain API, it allows you to track the flow of goods. What we realized is, corresponding to the flow of goods, there's also the flow of money that goes in the other direction. And given that we are embedded in this Bitcoin financial community, we thought, is there something interesting we can do there? And so it seems like there is some unmet need there. in terms of trade finance, and we're looking at that. And another of the projects you're going to hear about today, I think from Sujata, here is going to be about a particular application to trade finance. And so we're still understanding the space and trying to develop for it, but this will be an early example of what's possible. And like Robert said, I was a student here in the first cohort, and I now work at Skew, and we are hiring, and in particular, we're looking for strong full stack developers with interest more towards the front end and mobile, but any kind of interest that you have in the technology, please come and talk to me. Thank you.
Thank you, Wanda. And we've left some cards from Skew at the front desk as you go out the door if you happen to want to take a card. So first up tonight, and by the way, we have a great lineup. We'll do five projects. Now, by the way, these aren't startups. These are projects, okay? These are class projects. People came to the course not knowing each other, not knowing how to code on blockchain. They've just been together a little over 6 weeks almost. And so these are very raw and mostly in the idea stage. But Sujata Menon here will pull her team together. And Sujata has her Master's of Science from Karnataka University, and Jack Parkin is from Western Sydney. He's working on his PhD there. She also has on our team Tom Eagleson, who's with Accenture, and Chris Arneson is also a PhD. So she packs a good punch here. She's working on the API from Skew called ThingChain. Please take it away, Sujata.
Thank you, Robert. I think I'll give the microphone to Jack.
Yeah, okay.
Who's presenting the first few slides.
Awesome. Well, good evening, everyone. I'm Jack Parkin, as Robert said, and this is Sujata, and we're presenting Squirrel today. This is built on top of the Skew and using the BitGo API. So what we've developed is a secure and transparent and auditable system for financing purchase orders by making the flow of money symbiotic with the flow of products. So here's the traditional way of financing a contractor to get products from a vendor. Let me just work out how to do the laser pen. Oh, wrong way. So traditionally, there's a trust issue here, which means the contractor is bundled with a lot of risk, just in case the vendor doesn't produce the goods. So many manufacturers today can't get financing for purchase orders because of the lack of transparency in the system. So what Squirrel does is it provides financing based on smart contracts and tailored escrows to trigger the release of money with the movement of goods. So just to give you an idea of the market value at the moment, the current letter of credit market is $2.3 trillion, and the international trade market is $23 trillion. So even a small penetration of this market would be bringing quite a bit of returns. So this is a use case. In this situation, the contractor is building a tree house and getting wood from the vendor, and they need $100 to get the wood, but they only have $50. So they come to Squirrel for financing. Squirrel do a credit check on the contractor and then agree to match the other $50. So what we do, we set up a smart contract and an escrow where we both feed in $50 into the escrow, and once that's full, we need a signature from the contractor, Squirrel and BitGo for the next stage to happen. So once that we've got that, we send a purchase order to the vendor, and the money stays in the escrow for everyone to see. We then apply a pop code. Well, the vendor applies a pop code to the goods, and we use the Skew ThingChain API to give the goods a digital identity. They then send the goods to the contractor, who then scans the product, which releases which triggers the smart contract to release the funds from the escrow. And I'm going to pass you over to Sujata now to give you a demo of our product. We've actually only been doing this for a week. We started on Tuesday, so it's in its infancy.
Thank you, Jack, for a great introduction. like Jack mentioned, we started last Tuesday, so this project is a bit raw. I'll try to do as much demo as I can. Let's start with the demo. So this is a Squirrel application. So I put in a lot of, I set up a lot of profiles already in the Squirrel database, just so that the demo goes smooth. The reason why I had to do that was there's quite a few setup that involves with Go, and it could take like up to 5 minutes for each of those things to finish. And since Robert told us we had to wrap it up within 6 minutes, I have actually kind of like made the profiles beforehand. So this is the contract. Someone comes into Squirrel, and like after this project is done, we'll actually finish this project in a nicer way, not the basic 1996 HTML. We'll do a modern UI as well. But this is just to give you guys the idea of what we're trying to do here. So this is your contract where Bob is your buyer and Sam is the seller. So what's going on here is Sam is coming into Squirrel and he says he needs some money to finance this so he can make the goods. And he also puts in information. This is actually a smart contract that we're doing right here. He says there's a vendor called Victor that he's going to be using, and for whom, actually if you look at the loan amount, it's 0.5 Bitcoin. I know it's very trivial because my demo is based on a testnet and we don't have enough Bitcoins there. So it's going to be a very tiny, small fraction that's going to be moving around between the escrow and the vendors and the sellers. So the vendor, Victor, is going to be getting 0.1 Bitcoin if he finishes a certain task with the pop code. I'll be demoing that, the pop code, and how the money is going to be moving into that. So Sam is coming into this application and he's saying 0.5 Bitcoins is what he needs, but in real world it could be thousands, or it could be many thousands. Oops. So we'll go from here. This is the context of the application that we're trying to build, and I'm going to do a submit on this. And so what happens is Squirrel is the application that's going to do the credit check of the contractor and the buyer as well, and figure out for this particular project the number. What is the number that Squirrel is going to put in? For each contract, it could be different based on the credit worthiness of the folks. But here, just to demonstrate the idea that we've been working on, we decided we'll just do 50-50. It makes the demo much simpler to go through. When you try to add satoshis and things like that, it can get really complex. So 50-50 is what we're going for this demo right now. So what this means is Sam needs to put in 0.25 Bitcoins, and Squirrel is going to fund 0.25. And this money is going to be sitting in an escrow. And we decided to use BitGo API to get this done because we felt like it suited our purpose. Oh my gosh. Okay, let me click on this. So right now what's going on is we created an address. We're going to be sending this to Sam to fund. We actually what we tried to do in the application is we created 2 Bitcoin addresses, one for Squirrel to fund, one for Squirrel to put in the 0.25 Bitcoins, and the other address is for Sam the seller to put in the 0.25 Bitcoins. So we sent off the Bitcoin address to each of the application and Sam the seller. So let's see how we're going to be funding this escrow. So I have already gone into BitGo and created a wallet. This is easily done at the SDK level as well. This is just so it makes the demo simple. So I've created this particular wallet where there are 2 users right now. One is SquirrelTest2.vcu. This is a Squirrel person. And the other one is like SquirrelTest2.contractor. So these 2 people are set up in this particular wallet. And when anybody spends money from this particular wallet, what happens is the other person has to actually approve. I'll go through it pretty quick right now. So the escrow needs to be funded. So when someone comes into Squirrel and tries to create a contract, it could be like, up to a week. If it's a huge project, it could be a week, or it could be any number of days that they can take to fund the project. So what happens with the Squirrel application is it actually waits for that amount of time before it needs to figure out that the escrow is funded first. And then once the escrow is funded, what it's going to do is it's going to be waiting for the rest of the steps in the smart contract. The contract says it has to wait for one of the pop codes that the vendor is finishing. So first it waits for the escrow to be funded, and then it says this is actually funded. And then it goes into another kind of like a webhook for waiting for each of the pop codes to show up. So I didn't get a chance to fund this. Let me see. This is one of the addresses. Do you have a couple more minutes? 1 more minute? Okay.
Explain the rest of
Oh, okay. So essentially, what we're planning to demonstrate today is, so we're planning to demonstrate two important concepts: how the escrow is built. The escrow needs to be built within the certain time. There's a deadline for the escrow to be built by these two parties that are interested. It could be any number of parties, but for now, just for this particular demo, we wanted to stop it at 2 different people. And then once the escrow is funded, it goes into another loop concept where it waits for each of the pop codes to show up from the thing chain. So when the vendor is finished their side of the work, they're going to create a pop code for example, in this treehouse example, if the vendor was going to be making like 1,000 slats of wood, when they have shipped it, they would create a pop code on that. And then when Sam, the seller, takes possession of the pop code, it gets moved. The pop code takes the identity of the Sam, the seller, and from the application, we are tracking for this pop code to show up on the thing chain blockchain. And once we track it and see the pop code has been transferred, what we do is from the escrow, we move the 0.1 Bitcoins to Victor. And the beauty of Bitco API is money cannot be moved by anybody else. And when the Squirrel or the other person tries to move money out, they both need to agree. And there's an email sent to each other, and they have to agree on that. And once it's agreed that 0.1 BTC would be going out to Victor, because we've been keeping track of the thing chain blockchain for the particular pop code, and once the pop code shows up, we send the money over to Victor. So that's the gist of the project. I wanted to show you guys more money movement, but I guess we're out of time. But we could show you this demo at a different meetup too. Be happy to do that.
Tim Swanson's here with a couple of guys. If just wondering if you have any questions. We'll do some questions by your stand. Okay, so great. And coming up next is Jesse Posner. Also, Sujata is a mentor at Hackbright. So she's a mentor at Hackbright. This is the women's coding school, engineering school. So it's another nice project that she has. And so thanks. That's a very ambitious project, as you can see. And they just started a few days ago. Come right up. And so I look forward to seeing that develop. And next up we have Jesse Posner with his friend Martin. And Martin's from a startup called Brief.ai. It's a very brief startup called Brief.ai. And startup founder, it's live. And Jesse Posner is a startup lawyer and also part of Cohort 2. He'll be showing us Chainmail. So unlike Sujata's project, which was not on the Bitcoin blockchain, Chainmail is a way of doing emails with potentially a Bitcoin blockchain or other blockchains. So I'll let Jesse describe more in detail. All right. And just 1 minute, please. So we'll do 5 of these projects, then we'll take a break, and then we'll come back for another 3 projects. So, okay, take it away, Jesse.
All right, hello everyone. I'm here with Chainmail with my my friend Martin, and we built Chainmail. And Chainmail is a way of authenticating emails to provide an easy and powerful way to prove delivery of an email. And so the problem that we were looking at to solve is that email records are relatively insecure. You can save an email to your hard drive, but it's easy to open up that email, change what is in the file, and so you need to resort to extrinsic sources of evidence to authenticate the email, such as testimony from specific people or tracking down email servers. So it's expensive to authenticate emails in litigation because you have to go through this process to do so. It also makes it so certain workflows can't be fully automated because oftentimes you need to resort to certified mail or FedEx for important documents where you want it to be easy to authenticate the delivery of the message. And so our objectives for this system that we want to create was a way to have email records that are self-authenticating, that they would be time-stamped, that they would be globally readable, that they would be always accessible, immutable, there would be no reliance on a third party, and there would be no storage of private information. So the way we did this is to have an email be sent by a disinterested third party, which would be Chainmail. As Chainmail creates a certificate that contains the contents of the email and evidence of its delivery, which is our notification from the recipient mail server that the mail server accepted the message. We generate a hash value of the certificate, and then we send a Bitcoin transaction with the hash value of the certificate in the op return section of the transaction, so that hash of the certificate is then forever in the Bitcoin blockchain. So now let me show you how this works. So this is the Chainmail landing page, and so we're going to go to sign up, and I'm going to log in. And so one goal for this product is to have the ability to send through Chainmail integrated into the mail client itself. But for now, we have this great web-based interface. So I'm going to put in who the message is going to go to, subject, and then I will send this email. So, so we can see here this email was just sent here on May 19th. The status is accepted, and so if I go over to my mail client here, I see that I just received a message from Chainmail telling me that my message was delivered, and so in this email I received from Chainmail, I have the transaction ID of the Bitcoin transaction that was broadcast and the hash of the record, and then I have the receipt here that contains the raw headers, the status of the message as delivered. And then if I take this transaction ID and put it into a blockchain explorer, here's the transaction. It's unconfirmed at the moment, but it will actually be written into the Bitcoin blockchain as soon as it's confirmed. And we can see here the op return that contains the hash of the certificate. And so now Martin's going to tell you a little bit about how this was all put together.
Yeah, so we used a series of APIs to build this really quite rapidly, actually. The core for message transmission is the Mailgun API with Rackspace. The application is built in Node with the MongoDB backends. And then we're using Chain.com as our primary API. Quick note about Chain is they don't actually support op return transactions with their API yet. You still have to build the transaction manually with whatever your client-side code library looks like. But I talked to them over email, and it sounds like they're working on that. And then we authenticate everyone through another service called StormPath. It's pretty simple right now. Our goal in the future would be to actually build our own mail server so that we could, as part of the receipt, show the exact logs between the two mail servers that are communicating the message. And we want to add that into the receipt, and it gives an extra level of understanding of exactly what happened to your message, that it did get into the customer's mailbox.
Give it up to Chainmail. Thank you, Martin Anderson and Jesse Posner. Up next, we have Greg Ziegler from BitPay, along with Elise Lefebvre. She's from Montreal, and she's gasping how I pronounce her name. She was product manager at Monkey Inferno, and now has taken a new job as one of the 50th persons at Earnest, which is a startup which is refinancing student loans. She had like 10 job offers, but she decided on that one. And so and John Semmel on that.
They didn't actually have a Q&A for the last presentation. It's not coming up. Oh, I switch? Yeah. So for the channel, the only thing is for this. It's like Google Assistant.
The question is, why would you try to send it to them?
Yeah, and how was it? I mean, I'm just not sure how that's things that the email open to change. So is that the test?
So this hash, whatever document they sent was certificate from the test that you sent to them. It's a good one too.
I'm sorry, I just need to close this. Here. Alright, 6 weeks ago, at the very first class here at Blockchain University, Atif Nassim taught us about base 58 encoding and how that base 58 encoding is what gives Bitcoin addresses their really distinctive look of 32 random numbers and letters in a row. And Atif made me start thinking about, is there maybe a better way or a friendlier way that we could display or even identify Bitcoin addresses besides that one? And at the same time, I was realizing that lately when people ask me my friends ask me, how does Bitcoin work? I would always start by saying, it's like sending email, except you're sending money. And they get that, because they are experts at sending and receiving email. So Elise and Rick and I asked ourselves, is there some way that we can make sending Bitcoin as easy and familiar as sending email? And so this is what we built. switch over to Verizon. All right, so I want Rick to send me some money. I don't actually want to have to share my public Bitcoin address with every one of my friends one at a time. So what I'm going to do is I'm going to register my public Bitcoin address and my email address at a Carat registry. We used Python and Bottle and MySQL to build this server. So what we wanted to make sure is that the email address that you enter really belongs to you. So we use SendGrid to send out a confirmation email, and the address you just enter won't work until you actually confirm you own that email address. So now I call up Rick and I say, please send me some money. So this is a reference implementation of the Carat protocol, and we use Copay open source Bitcoin wallet and Chrome extensions and JavaScript and the color orange. Here is where the magic happens. All right, so Rick, we've been exchanging emails, so he just types in my email address. And where is that? Here. And don't blink. And it goes ahead and the wallet will actually replace that with a Bitcoin address that I just registered, and also will tell me where that information came from. And then Rick sends that out, and there it is, it's in my wallet. So back to this one. So what we wanted was an open protocol that minimizes trust in third parties, that maximizes use of familiar identifiers like email addresses, and that brings in new kinds of businesses into the Bitcoin ecosystem. So this is what we came up with. So the first thing that happened when Rick typed in my address in the wallet, the wallet looks in for local storage and says, do I have a Bitcoin address for Greg Ziegler? And that might look like, the Satoshi client has the address book with labels, so it might look like that, or it might be like the mobile OS might have a contact list that you can tag with Bitcoin addresses. When it didn't find that locally, it went ahead and it contacted Gmail, which is my email service provider, and it just built a URL like this and sent it out. Google could build that API internally using, say, blockchain technology, or it might use something else. It's really kind of open to how it wants to do that. When it didn't get the response from Gmail, it looked in the wallet preferences and looked who the names registry is, and created this URL and sent it out, and it got that back. So what the payload of that API is uses the netkey message format, and it just has these three properties. Netkey uses Namecoin to guarantee unique wallet names, and Carat here uses email names. And you can just imagine what other kinds of wallet identifiers might be in there instead of email addresses, so it's very extensible. So Rick and Elise and I hope that by supporting an open protocol that minimizes trust and maximizes the familiar, that businesses and wallet developers will be able to lead more and more customers into the Bitcoin ecosystem.
Give it up for Carat.
Any questions?
We'll take questions at the end.
Oh, okay.
So next up is John Siddiq and Damian Gomez. Damian's a student of psychology. Siddiq has just finished his master's in computer science here in the Valley. And John Semmel comes up to us every week from LA, like, your wings hurt from all that flying? Actually, he used to be a Mets baseball player. He was in the minor leagues of the Mets, and he's going to present to us Collectibles.
All right, everybody. Thank you for the intro. I'm John. This is Sadiq. This is Damien. We are Collectible. Digital sports memorabilia is what we did our project around. So, sports memorabilia. Fans derive value from sports memorabilia. Why? To express their passion, maybe in a favorite team or maybe a player. But also, if you were looking to invest in an asset, sports memorabilia is actually, we think it's around a $1.5 billion market. But what's the problem? Well, there's a guessing game when you buy sports cards or when you buy sports memorabilia. When you walk into a shop or at a trade show or on a secondary market, you want to know if that product's authentic, and you want to know who the last owner was and what the price he paid for it was. So there's been all these services that have popped up to authenticate a baseball card. You know, whether it's PSA or Beckett, these authentication services act as an authenticator, but also as a reseller. So it's a coincidence that the authenticators have a subsidiary magazine which pegs prices to specific sports memorabilia. So this kind of fragmentation really creates a hard market to buy in, and you really have to know what you're doing in order to make a profit in buying sports memorabilia. So what if we could provide a solution? What if we could provide a ownership history, a provenance history, and a price chain associated with that card and that piece of memorabilia? So you were able to go to a card store or go to a secondary market and scan a card and see that card's history, see its price, see its ownership trail. So what we thought, along with the thing chain, would be to provide a pop code, a proof of provenance embedded into a baseball card, and when that pop code is minted, its value, origin, and contents are written into the blockchain. This chain of custody shows the unique history of each card, and really what we're after is we really want the consumer to determine the marketplace. We don't want a secondary market to be created, whether that be in eBay, whether that be in a trade show or a card authenticator. So what's our entry point? I mean, it's hard. Are we going to be a baseball card manufacturer, or are we going to go cut a deal with a baseball card company? So our first idea was kind of align with a youth sports organization that maybe deals with elite athletes and insert a pop code and actually create baseball cards with that amateur sports company, and thereby we wouldn't need to go get an MLB license. We could just partner with that amateur club, and there are a few clubs out there. This one happens to be called Area Code Baseball that deals with elite amateur athletes. You can see Mike Trout there, Bryce Harper, Giancarlo Stanton, Albert Pujols. Imagine if you were able to get the next star at 17 or 18, and you would be able to really track that provenance of the card when it was created, and when that 17-year-old had the card in his hand. You could see 30 years later that that card came from that specific person. And the second entry point is the backdoor, and really we'd use our app to derive a pop code from the authentication company's unique card identifier, whether that was on a Skew or just a number. And I'm going to pass it off to Sadiq now, and he's going to get into kind of the technical details of our app.
So a brief intro that I was more of a cricket person. I know that baseball was something related to, it has a bat and a ball, so I related like that. But after meeting John, I came to know that people pay a lot of money for this. And I was like, yes, we're gonna do it. So we came up with this, and we didn't have much time. So I decided let's create a prototype to show what John just explained you. So our first use case is I'm a seller and I'm going to sell this card to John. Before, there was only one PSA or some company that authenticate. Nobody knows who is the correct owner, or maybe I can steal and sell it. With our app, John can come to know that I'm the rightful owner. So you can see now. So you just go and say scan pop code. Scan the pop code and yeah, I'm the owner. Now I can give this to John. This we complete our first use case. Next, coming to our second use case. Now John wants to become the owner of this card. So what John has to do is just sign up or then log into our app. Then he has to take the ownership. The pop code has the value. The value will be given to John. John will scan the card, enter all the details, I mean like price, whatever he wants to enter, and the message and his public address, and bang, John is now the owner of the card. Not only that, John can verify, John can see what he owns by going to the account. As you can see, he's currently having this card. He can sell using our app. We are planning to have our market. Here is the card. Before, John has to go to eBay or maybe Craigslist, and I don't know where he has to go to buy these cards. Now he can just use our app to buy the cards. And we are planning to bring a platform where people with so much craze can not only buy, not only sell, can connect. So one example is this. So based on your geolocation, you will come to know who are the people nearby who are selling or interested in buying. So if you just double tap, you can see that this guy is selling this old judge card and this guy is looking for this card, and basically you can connect. And one more feature is finding the chain of ownership. John explained me how important it is to know that there are list of owners or how old the card is. So we came up with one more use case is that finding the chain of ownership. And sometimes it happens. So now it's back. So you can see the first owner was John, second was Mike, and third owner was me, and the fourth owner would be John. So this was our app, and Damien was working on implementing the app. I guess he has something to explain.
Yeah, I want to show you guys, I guess I'm going to go over just the first initial screen of the Q code scanner. And so just going over that and see if that makes sense to any of you guys, and I hope it does. Okay, so essentially from the previous use case that Sadiq mentioned, we need a code to serialize through the data that's instanced when the camera session's opened. And so I have no idea how to,
That's okay then.
to make the font bigger. So essentially this class is an extension of the serializable class in Java. It implements the next two screens. I'll show you activity and screen. Basically the entire process instance, when we open the logo button, upon touching that, it starts an instance of the iteration open app. Once it does that in the activity class, we have the, apologies for that. So open app, and from open app we get a new screen to open screen. Open screen would then take into consideration the this hex code. This hex code is the opener for the port that then translates into the namespace in the XML file, so that upon instancing the Android manifest and the activity XML file, we have the byte sequence for that hex code. It's now instanced as you try to catch the entire package. And then it's not taken together until this point in time here, where we have the actual pointer getting the actual instantiation of try catch, which is now the byte sequence of the entire package here, through a direct queue pointer.
About 30 more seconds.
Yeah, in essence, as you go down, you get the codes, you focus the camera. At this point, you want these 3 abstract bytes to then match the current thread process that's happening. Upon that, you get the ID back. You can scan the code at that point where the frames that are on top of each other then match. Upon that instance of the focusing of the actual frame that's in the activity XML file, then you can scan the code and you can serialize it at these particular sequences. You can then parcel it, get the byte stream array into these, and then resolve both of them, and then send them back into the port to be released back into the database. So, yeah.
Awesome. We're a collectible.
Wow. And they have a psychologist who codes. Now that's awesome. Thanks, Dan.
Thank you.
So next up, Michael Folkson, direct to us from Melbourne, Australia. He'll be presenting for us a P2P insurance platform. Buy insurance from your friend.
Okay, so hi, I'm Michael Folkeson, and the provisional brand name is MicroRisk, and the provisional strapline is a risk market for the digital age. One of the most important things I want you to take away from this is that insurance, betting, decision making, and investing are all one and the same. They utilize stakes and they utilize odds. The stakes and the odds will vary, but in essence, all of those things rely on those 2 aspects. So let's get the creative juices going and imagine what a future world of insurance might look like. In this example, Alice has agreed on a dating website to go on a date with Bob. But Bob has been on dates before and has been stood up on various occasions in the past, and isn't looking forward to being stood up again. Another individual, Chris, is seeking to make profitable bets on the future. Now, in this example, Bob is willing to pay a premium to be compensated on the event that he is stood up on the date. Chris is looking for an opportunity to make a return. As we all know, bonds are yielding next to zero, equities are very expensive, everyone's on the lookout for a return. So going back to the discussion around the difference between insurance, betting, investing, and decision making. Now, a standard definition of insurance is a guarantee of compensation for specified loss or damage in return for the payment of the premium. Insurance has quite a bit of an image problem in that it's not particularly glamorous, and we don't particularly want to think about it much. We want to get it sorted and organised as quickly as possible without giving it much thought. We don't want to think about terrible things happening to us like earthquakes and our houses burning down. But as I said before, stakes, odds, and also in this case perception. The stakes are what you're willing to pay for a premium, and the odds are what's the chance of that event actually happening. Now, in contrast, betting is rather glamorous, as seen by these pictures up here. Now, I would say that insurance is a much more valuable product than betting. Yet betting has a much more positive image. It's more exciting, it's more glamorous. Again, whether you're on the roulette wheel or whatever you're playing, you are determining odds and you're determining which stakes you want to place on those odds. So my idea is peer-to-peer insurance. We're all very familiar with peer-to-peer lenders. Have been incredibly successful over the last few years. Lending Club, Prosper, and Zopa. Now, before they came out, the traditional financial industry would have been very, very sceptical that they'd work. Surely you're required to go through a traditional institution called a bank and use their risk analysts, use their expertise to be able to determine what interest rates to charge on loans. But companies like Lending Club have been very, very successful at cutting out the middleman and just allowing peers to lend to each other and determine the interest rates independently without having to go through that third party. And so micro-risk, in a similar way, will provide a platform for individuals to provide insurance to other individuals. So one example of insurance on the blockchain will be this one. So at the moment, similar to a bank, every insurer will currently maintain a large centralized transaction ledger. And as we all know, because we're here for a blockchain university session, that's not an ideal scenario now that we have this wonderful invention called the blockchain. So how about, in a similar way to banking, why can't we, with insurance, shift from a centralized model to a decentralized model which relies on peer-to-peer and mutual insurance platforms? Now, one particular example would be an Uber driver who wants to purchase insurance. Now, typically, in today's world, you'll buy an insurance policy and there'll be a fixed premium, perhaps monthly or annual. But why not, can you not have in real time coverage varying with the number of rides you give and premiums varying with how safe your driving is and how many journeys you're accepting? It's quite antiquated to think that no matter what your behaviour, you'll still pay the same premium and be provided the same coverage as the next Uber driver. How much more time have I got? 2 minutes. Another example is, so this is a smart insurance contract where a crop insurer is worried that there won't be rain, there won't be precipitation over the next 20 days. Now, one potential solution for this would be a smart contract where weather data is fed from a national weather service so that funds are released to this farmer on the eventuality that there isn't rain over the next 20 days. An alternative, as the previous team described, is escrow, where perhaps the funds will only be provided to that farmer on validation by the insurance provider. Another example is mutual insurance. So with a very large family like the family pictured, there's no reason why they can't all insure each other and not have to go through this third-party insurer. If they all contribute premiums to a pool using a blockchain, then they don't have to surrender profits to a third party, the insurer, and they can all provide the necessary insurance coverage within their extended family. So to simplify, the business model is matching insurance providers with consumers, cutting out the middleman, cutting out the third party with all the perhaps unnecessary complexity and profit surrendering that it is entailed. So this platform does not provide insurance, it merely matches providers of insurance with people who require insurance. And the benefits are cheaper insurance for the buyers, insurance coverage like in the dating example that can't be purchased at conventional insurers. And for sellers, there's profit-making opportunities, diversification in their investment portfolios, and also it could be quite fun. It could be enjoyable to get an insight into people's lives and the risks that people get really, really concerned about. I won't go too much into the ethics of the business model, but I will leave on this quote that I think is excellent in terms of explaining the value of insurance. So, insurance enables us to breathe more easily, to find the confidence to let innovation flourish, and to engage with the present and the future, chastened by the past, but not allowing the fear of the possible to paralyse us in the present. And I think this is why risks that we might worry about, perhaps unnecessarily, if we could just purchase insurance coverage for those risks, we would feel as if we're on a much sounder footing going forward into the future. So that's my idea. Thank you.
Thanks, Michael Folkson from Australia. So right before break, I'd like to do a quick raffle here. People gave their business cards and whatnot, and so Lillian, why don't you hold this here, and we'll pick a name out of here. Let's see. Wait, that's me. Hold on, this thing is rigged. No. Hold on, let's see. Let's try maybe like this one. Judy Chang. Welcome to a free class at Blockchain University. Yay! We'll have another raffle at the end of the night. Please come up, Judy, and receive your free scholarship to Blockchain University, Cohort 2, starting in June. Special San Francisco cohort.
Thank you.
Just stay in touch. Thanks a lot, Judy.
Thank you.
We'll take a short break and be back in here in 10 minutes for the last three projects. We have the inventor of SSL. We have Kiara Robles, who's a force of nature, and we have a serial hackathon winner. Come back. 10 minutes. If you have any standards.
Well, I already have some statistics you were saying.
So, do you have any like printers or anything like that? Because Rich Photo does, he's got 3D printers, and one thing we could do is maybe like create a QR code. Jared Holtz and Matthew Schutte are running Collaborative Advantage, CA Labs, aka CA Labs, as well as Christopher Allen, who invented the SSL standard, as well as he runs the iOS Developer Hackathon, which is coming up in July 11, July 10, 11, and 12. So check out the iOS Developer Hackathon, which will be at eBay this year. Wonderful. Take it away, guys.
All right, so we are Revoke SSL, certificate revocation that actually works. Our vision, if an SSL security certificate is an I love you, with us you can take it back, right? Revocation at the click of a button, even for self-signed certificates. Our team, as Robert had mentioned, is Christopher Allen. He's our CTO. He is the co-author of the TLS protocol, more popularly known as SSL. That is the most popular security standard on the planet. I'm Matthew Schutte. This is Jared Holtz, who is still frantically fixing things for the demo. Traction. So like some of the other teams, this idea is new. The basic concept Christopher came up with a couple weeks ago. We think we've stumbled upon a business model about 4 days ago. In that last 4 days, we've gotten interest from a medical payments company, an online media service, a media discovery service, as well as a retailer that does over $1 billion a year in between their online and their real-world in-store transactions. The market opportunity. So, revocation is hard right now. People issue security certificates, but if something goes wrong, they go, hey, we revoke that, I take that back. And it's not very easy for them to communicate that reliably to users. Our focus is on helping enterprise server security professionals, so the people that are managing the server for an enterprise company, communicate more clearly about the status of their systems. The opportunity, it's a $4.5 billion market today for certificate authorities issuing certificates. That's growing at 20% a year. There's also an untapped market for self-signed certificates. So the way that this stuff basically works is you go to a certificate authority and say, hey, will you vouch for me? And they give you a certificate. Right? There's a separate thing where you go, I vouch for me. But people are only able to use that in limited ways today. We think we can open that up quite a bit. Currently, there is no way to revoke a self-signed SSL security certificate. So if you make it yourself, all of the existing revocation methods are dependent on a certificate authority, a VeriSign, a GoDaddy, somebody like that, them saying, oh, this thing has been taken back. Since you are not a VeriSign or a GoDaddy, there's no way for you to say, hey, I take that back. Because of that, IT professionals do use self-signed certificates, but they use them only in limited contexts where they're trying to communicate with their own systems. They have trust already existing. They know themselves. They're not able to communicate with others. Current solutions don't use your self-signed certificates for anything but talking to yourself. Right? Don't talk to anybody else with them. Problems. One, it means you have to depend upon a certificate authority. You actually have to connect to them in order to validate this secure communication. And that represents a single point of failure during a compromise, whether that's an attack or some other kind of issue. Second problem, even if you got the certificate from VeriSign or GoDaddy or whoever, revoking one of their certificates doesn't work all that well either. We can go into that in more detail later, if any of you want to talk about it. But part of the problem is that they don't get used much. They work so poorly. In one study, half of the certificate revocation lists that got queried just didn't respond. And eventually Internet Explorer figured out, hey, it's a bigger problem that we're getting all these warnings to users, so they just turned off notifying people when there wasn't a response. Well, as I wrote here, a system that doesn't get used isn't much use. Right? The third problem, cost. When you want to use a certificate, it costs money. You get a certificate from a CA, from a certificate authority, it could be upwards of $2,000. Our product, Revoke SSL, we let enterprise IT staff create revocable certificates in minutes, regardless of whether that you're using a CA to create the actual underlying certificate or doing it through a self-signed certificate. You can revoke that certificate with one click of a button using our stuff, or completely independent of us remotely through a transaction on the blockchain. And anyone else can see, they can check to see if it's been revoked without having to ask us, without having to ask the CA. They can go look for themselves. So we'll do a quick demo.
Okay, so our target market is IT, so a lot of them are going to be using Squirrel for their commands to be able to do things. So I'm running two-handed. So we're going to basically create our certificate, and it's basically.
Can you make it bigger?
Yeah. So basically, it's doing open SSLs, creating a certificate, but it's embedding some extra information in there. So I will basically show you what that is. You basically have all the information, the serial number of the certificate, but way up here in the organizational unit, we've added some extra information, which is the Bitcoin key. And we have a signature, etc. So at this point, I might want to see, is this certificate valid? So basically what I'm doing is I'm checking to see if the certificate's valid, and OpenSSL is claiming the certificate is valid, but it's basically also saying, wait, there's a Bitcoin in there. What's going on here? That nobody's claimed this particular certificate. So now I can claim this certificate. So I have to very quickly fund my little claim. So I'm going to go to here, give it some little money so I can fund my claim. So I've given it a bunch of testnet tokens. So now I'm basically going to do the same command. And you'll see here that it's basically created a transaction. It now has a value on the Bitcoin, in this case of $1. So if I run verify, it will basically tell me, hey, there is an unconfirmed balance of 40,000 Satoshis, which is about $1. It's awaiting network confirmation. And the whole point of Bitcoin is to prevent people from double spending, so it's trying to spread this fast. At this point, it's being sent out to thousands of servers and to all the different miners to, as fast as possible, make this transaction be confirmed. Basically, we don't have the 10 minutes, but within 10 minutes it will be confirmed. It will be on the blockchain. You will have a proof of existence of precisely when the certificate was on the chain, which means to insurance companies or other bodies, you can basically prove, yes, I did have a certificate and I had it on this day in the past. And then later, I can basically, when there's a compromise or there's a heart bleed or anything else like that, and I'm basically emptying the claim address, I could basically go to this transaction ID and now I have a proof of existence of the revocation when it happened. Completely separate from, I didn't have to talk to the CA, I can use back channels, I could have used a phone for this, I can actually even use a paper wallet, so I can even keep the keys in a safe deposit box for how I revoke things. And that's it.
Stealing the screen back. Okay. Revenue model. We've got some versions with UI for people who are not command line friendly. You can steal that. Revenue model. Basically, the initial pricing model, again, this is a few days old, so we have no idea really, but we'll see. Self-signed certificate, we're looking to sell those for $5 per certificate or on an annual subscription basis. So you're buying our service and you can write your own. That can be deployed today. We don't need any support from browsers because the browsers aren't supporting self-signed certificates anyway. Future revenue models, we think we can do revocable server-to-server SSH keys. Basically, this solves a different problem for the same market. Those same IT professionals could now all of a sudden be using revocable SSH keys as well. Separately, a possible charge per certificate for CA certificates. Again, that's something you get from VeriSign. We can make that revocable too. But that's the same market. We're serving the same people, but it may require browser adoption. I'll just
read the quote.
The quote. Okay, we talked to somebody from an enterprise company. She said if it was recommended, we'd pay $150 for revocation services on a $500 EV certificate. So we've got folks in business saying we'll pay you $150 for that if the standards folks said yes, this is a good idea. Marketing and growth. Today's customers are using those revocation services that don't work. How are we going to reach out to our customers? Basically, local meetups here in the Bay Area initially, as well as conferences. There's a number of conferences for infrastructure and operations folks. Exit strategy. Our operations cost should hopefully remain low because we don't have to use centralized infrastructure. We're being able to piggyback on the blockchain for where we're storing all of this stuff. We're not yet sure what our user acquisition costs will be, so we'll have to figure that out. Potential acquisitions by any of the big certificate authorities or Microsoft, who happens to be the 500-pound gorilla in the space. Anything they do, they sort of demand things of certificate authorities, and then the certificate authorities basically respond and are kind of, I was going to use a bad word, but they get told what to do. Competition. Currently, revocation is bundled with the issuance of a certificate from a CA. It works poorly and is actually a cost center for those CAs. So they're not a fan of this either. We are an independent revocation service provider. The advantages: revocation that actually works and fast. It works with self-signed certificates. Privacy concerns that occur in the existing infrastructure are addressed. And there's a cost savings even for the issuing CAs today. We are looking for investment. We're looking for 6 months of funding to demonstrate product market fit. That's basically a functional minimum viable product and paying customers. We're seeking a $200,000 convertible note sometime over the next 30 to 60 days. The use of those proceeds are basically going to pay our salaries at a Bay Area living wage, funding one enterprise developer to help build out some of the infrastructure, and a little bit of sales and marketing for going and attending those conferences. Contact information, email Chris if you're interested, and that's it. We are Revoke SSL. Thank you. We can take questions afterwards at the end. Thank you.
Thanks. Revocable. And now we have Kiara Robles. And she's presenting
Blockchain me made it blockchain you.
So I know everyone in this room is definitely an advocate for Bitcoin, and just by a raise of hands, how many people have heard of PGP or PGP encryption? Okay, so also most of the room, there's a lot of overlap in those communities. Encryption and Bitcoin go together very well. So when I first started this class, I really wanted to bring that together in one solid project. If you want to follow along this presentation, I posted on Twitter as well. So this is a hard copy ID that you would be able to get through the web application at blockchainme.com. Would be entitled blockchain.me, but that website was taken and the owners want $13,000 for it. Just like, or similar to the private key and public key of the Bitcoin technology, PGP encryption also uses that similar function. So what the web application does is, in very simple steps, it allows you to generate PGP keys on the website, allows you to choose what information you want on the ID, and it's verifiable on the blockchain for people that you want to give the file of your ID to. So in Oakland, they tried to blend IDs with a payment plan, like here it's debit and MasterCard. You could do that as well. Instead of a picture, you could have a QR wallet on your ID. This is an old driver's license from California. If you could see on the upper right-hand corner, it actually has that he is not married on the ID, and you can include that kind of information as well if that's something you wanted to do. It's open, and it's trying to push the flexible limit of identity. Like what do you consider to be important? You could put your Facebook number on there if that's relevant to you and your contextual identity. So the third step on the website is actually to sign your ID that you filled out with the PGP key that you've either generated or have created on command line yourself, and that's how you would authenticate the ID. That would take the place of a central authority. You would create a network through PGP using the Web of Trust and signing other people's keys, or IDs in this case. So this is the blockchain proof of existence. This is a blockchain class, so obviously this is the meat of what I'm trying to get at here. If you go to this block in any block viewer, you'll see a list of transactions, and if you go down to this one right here, in blue, this address actually corresponds to the information on my ID. So if I were to give you a copy of my ID with a link to the file, you would be able to verify that this is the address that corresponds to that ID, and it would be very rare that you would get a collision, and it's the uniqueness of the identity is not necessarily in the name or the content, it's in the address that you send the proof of existence to. And here you'll see that I sent 0.100 Bitcoin, which is about 25 cents, a lot cheaper than any ID I bought at the DMV. So the fifth step of the website, which I will show you soon, is actually just to order the hard copy of the ID, or you could get an email of a PDF where you could make your own. This is kind of geared to people who are new to Bitcoin, new to encryption, and are looking to understand more applications than just it as a currency. So, like I said, I'm trying to integrate the Web of Trust, and that's what I'm showing here, signing people's keys. That would be part of the network. If you're interested in learning more about proof of existence, the next presenter will demonstrate that a little bit further, but I've also posted some resources here to help you understand how you go from a file to an address. These are some of the open source projects that I've used. My project is also open source. I used Crypto.js for most of the functions that I needed, and I will move on now to show you a demo. If you want to follow the project, I think I might continue this past the class, and you can find it here. So let's go down to the website. If you click on ID on the corner, this is where you would generate your PGP keys. I also have a command line reference on the side for people who prefer that. So let's generate keys. Copy your private key because that'll be needed for the signature. So at this point right here, step 2, this is where you would include the information that you deem relevant for your contextual identity. Again, like I said, you don't have to trust me with your private key. This could all be done, and there is a guide to do this on your computer locally. But for people who want to, I think that this is a good option. So here in step 3, you signed your ID. And in step 4, you would take it to whatever proof of existence website you want to use. And it would take, I just choose BT Proof because you can actually copy and paste just pure text documents in here and not have to upload a file. But it is kind of important to save the result of the signing, because that's what people need to confirm that your ID is on the blockchain. The address that you send the funds to, and the ID to confirm that it hasn't been tampered with and whatnot. So that's the project. Thank you for listening.
Up next, we have Lillian Chen, Roman Storm, David Bentley, and Igor Baranov. Igor's a serial hackathon winner, among other things. Take it away with Block Notary.
Thank you very much, Robert. And we're going to build the drama. Okay, so we are Block Notary, and what we wanted to do is to create an easier way to show that you are the creator and the owner of the photos, videos, text, and any other electronic file that you might create. Now, legally speaking, a copyright exists as soon as you create something, but sometimes it can be difficult to prove that you were the first to come up with that thing. So, in the old days, you might email this file to yourself or friends, but as we heard from Chainmail, that can sometimes be difficult and not necessarily accepted by courts. Or you could get documents notarized, or you could get a statement from a third party. Well, of course, the blockchain is the natural way to verify your documents. So, yes, there are websites where you can currently upload a file, hash that, and submit that to the blockchain. But we wanted to make this easier. So if you don't know anything about blockchains, bitcoins, we want you to still be able to store proof of existence in the blockchain. So, as you can see here, we've got a very cute dog, and it's very easy to use. He can use it just by mashing his paw against the screen 3 times. So the first step is you click on the app. The second step is you choose your file. The third step is you hit submit, and you can choose from these 3 different blockchains. And there are some other use cases. One would be proof of presence. So let's say that you have to prove that you're at a certain point in a certain point, you're at a certain place at a certain point of time. This might be because of work, because of a court order, or perhaps in her case because she has a jealous boyfriend. So what she's going to do is take a selfie, and she's going to submit this to the blockchain. And what will be actually in the op return is the embedded GPS date and time. And then one thing we haven't put in yet, but perhaps the photo is available on IPFS so that you can see it's actually her that was holding the phone and she just didn't give it to someone else. And finally, after it's submitted to the blockchain, a few minutes later, boom, a push notification comes to your phone, and it's just as simple as that. So now, we're going to have the most exciting parts, so you might want to move forward to the edge of your seat. And we're going to have a live demo, so take it away, Igor. Or
So, are you prepared? I have some apps here, and Block Notary actually is not an app to submit files to blockchain. Use different apps. For example, I'll start with camera. I'll make a photo of this class. So it's the step one. Step two is to press share and select Notary extension. We can activate it in activities as a standard way to activate it. So select Notary, and I have some options to put here, but actually I don't need anything. Just put some descriptions. Block chain you demo night. So yeah, and hash of this photo will stored forever. Well, image is successfully submitted, but where is it submitted to? Let's see. So as you know, blockchain confirmation is 10 minutes or less. So let's hope we are like on 9th minute. Here I have a list of all my documents I submitted. Let's see what do I have here. Well, I don't have block number yet because transaction is not completed, but I have transaction hash. And I have photo hash. Oh, I file confirmed. Well, lucky today, you know. Yeah, so we have block number already. Good way to invest right now, you know. So status confirmed, and you can see in well, the magic is in message field, you know, 521 C5 blah blah blah, and we have it here 521. Well, it's the same. So the same message in blockchain and the same hash in this app. I can save it to gallery, and later I can send it. But what if I need to notarize something? Well, I'm not a lawyer yet, but let me try to be a lawyer a little bit. So, for example, I have this document. Okay, so I scan it with third-party app called Scannable from company called Evernote. So Evernote is a big company, and they have great app, so I can make scans of documents. Well, I can share it later, and here is some way to share it. I can message, mail, Evernote, export, blah blah blah, and I have more. And if I press more, I have Notary button. So looks like our app already integrated with Evernote, yes? Yeah. So just press submit, and we have document from Evernote submitted to blockchain right now, out of the box. So it can be used with any app. Is it cool?
Awesome.
Yeah. So we prepared a landing with explanation of our service, and you can download, if you have an iPhone, you can download right now. If you have iOS 8 or greater version. So here is our team, and if I have a few seconds, I can. Let's take here. I want to tell a little bit about how it's created on server side. So we use parse.com to store all the data, so photos uploaded to cloud, and we perform hash function on phone and upload hash into the cloud also. And in the cloud we have jobs, and with this jobs, oh, so it's key here, okay. So we submit hash into blockchain using block cipher API. It's a very easy way to submit, and as you can see, it's very easy to integrate blockchain on Parse Cloud. And also, if Parse get hacked, it's a problem of Facebook. No, it's not my problem. So when I store keys in cloud, and I think it's well, it's a good way to perform transaction on server side.
So summarize. Yeah. Summarize.
Okay, so, yeah, so as he said, if you'd like to download this app, just go to blocknotary.com. It's right now just for your iPhone, but you should definitely check it out because it's pretty cool and it's only going to get better. Thank you very much.
Thank you.
Let's make a photo. Can you make the photo of us? Just for the
You guys can't do a selfie?
Yeah, we want to make.
Just 1 minute. So I'd like to introduce Tim Swanson, who will just reflect here a little bit and introduce Flavio and such.
Thanks. Yeah, hey guys, I won't take too much of your time. This is great. Thanks for the demos. Actually, I was a lot more impressed than I thought, especially after 6 weeks. You guys you had an abbreviated class, so hats off to you. I'm not sure if you guys know who Fabio is. You want to quickly introduce yourself?
Sure. Hey everybody, so I'm Fabio. I'm co-founder and CEO of Collectibles, where we work on data intelligence products on top of the blockchain. And yeah, Tim was kind enough to invite me today to judge and review some of the projects. And yeah, as he said, like very impressed with what the guys did in 6 weeks.
So yeah, let's just start off with the first demo with the letter of credit. This FYI, the Squirrel team, please come talk to me afterwards because there's some people in Singapore. I was just out there about a week ago. Some banks, they're really interested in doing, trying to do some pilots on streamlining the letter of credit system. So there's some real world applications. I'm not saying the rest of them didn't have it, but that was like immediately struck out to me. Did we have any questions for them?
What happens when the pop code is compromised, or how do you?
Yeah, how do you guys verify whether or not the pop code is compromised or not?
Rashil?
This is Rashil from Skew Chain, and so I think he can take this question. Come on up. Rashil from Skew Chain.
So just to jog you guys' memory, a POP code, POP stands for proof of provenance. So it's essentially a unique public private key pair on the blockchain. So when someone mints a POP code, it means they put value into that POP code and they declare its value, its contents, they embed whatever metadata they want in the op return. And so when someone takes possession of that POP code, they take the value from that POP code into their unique identity address. So if somebody were to try to photocopy that POP code and attach it to a counterfeit batch of goods, the buyer would not be able to take possession of it because the value would be with someone else.
Do you have any questions? Okay, you pass that test for now. Alright, who was the second group there? Was it Carat? Second group was Chainmail. So authenticating mail via hash value certificate. So there's actually several groups who've done that. So I guess that's a good validation of at least the idea. Do we have any questions for them? Oh yeah. The first one that stuck out to me is how do you get disinterested? You guys said you're a disinterested party. How do you prevent a man-in-the-middle attack between me sending you a document? How do you guys prevent or how do you prove that there hasn't been a man-in-the-middle?
Well, the email would be submitted using our web form.
And we have to trust your web form.
Have to trust the web form. There are ways using trusted certificates in email to validate email servers, and when we build our own email server, we'd be able to build in that kind of authentication. But the main thing that we're the main testimony that the disinterested third party is making is that this message was received by Chainmail and that it was therefore passed along to the blockchain. And so it's more about creating a presumption of evidence than necessarily creating 100% certainty, because it's about reducing the cost of authentication.
You're a lawyer, right?
Yes.
So, very lawyerly answer. Let's see. So the third group was that Carat? Yeah. So I like the name Carat. There's another group called Celery, and Maybe there'll be broccoli and radish. I mean, we have lots of vegetables to choose from. Low-hanging fruit. So the product was turn a BTC address into an email address, right? That's actually pretty helpful. I know there's a lot of people on Reddit. Like every week, there's somebody saying, "Oh, why is it so cumbersome? 33 characters." So the question we had for you is, have you guys looked at others like Bonafide or Keybase or OneName? Like, what would separate your guys' self? Oh, there you are, right here.
One of the things that stands out with this is that it's actually an open protocol, so that any service could actually implement that service, and it's up to wallet developers to fairly follow the rules as far as like go to the email service providers first, and then maybe go to a name registry. And it's open, and there's no one has a lock on that kind of data or that pattern of usage. So I think maybe that's where it distinguishes itself from the other proprietary solutions.
Proprietary. Shots fired. Okay. Let's see. Next group here was collectible. Two-way determination. So I just saw. I guess Ryan Orr's not here. I know. If you guys have a chance, obviously you know Skew Chain. There's some other groups that are kind of doing. One's called Ascribe. Yeah, Ascribe.io. So it's kind of a neat idea. What was the question you had? Yeah, how do you obfuscate ownership? Let's say you had the chain of people who previously owned it. You showed like 3 different owners. How can you add in some kind of method in case one of the owners don't want to be known? Is there a way that could be done, or does it always have to be transparent? Anyone here? Okay. Going once, twice? Sold? Eric, any idea? No? All right.
In that market.
Okay, well, let's go to the...
In that marketplace, they actually, the cultural convention is that it's not, there's some pride of passing along, so.
Oh, so that's like part of the deal? Like you're putting your name on there, it's kind of like part of the... Okay. What's next week? Micro is... Okay, so P2B Insurance. A group... who is that team still here? Yeah, hey, check out Route 66, one of the investors there, Pascal Bouvier. He was just in town. He's looking for P2P insurance plays. So I can't promise you that he'll invest in you. But so the question I had for you guys then would be identity. How do you do identity on a... Yeah, I didn't see how you actually put together identity with a blockchain. Is that something that's extra outside the box, or is this something you guys provide?
I don't quite know what you mean. So, for example, with a normal, say, Bitcoin transaction, you've got a pseudonymous public address. So, what do you mean by that?
So, is your company providing a way for people to actually identify themselves in order to actually create customer service? Or at some point, somebody's going to complain about not having losing a private key or something like that. How do you deal with that?
Yeah, there would certainly be services around auditing and validating claims. So, for example, I'll keep going back to the banking example, but with getting the bank out of the equation and relying on peer-to-peer transactions, that doesn't mean there won't be other companies providing services around peer-to-peer lending. And so, stripping out the various different services the insurance company provides, there will still be companies providing, say, audits on claims, but it will strip out each specific service that the insurance company provides, only leaving a small number of services that other companies will provide. Does that make sense?
Sure. Do you have any questions?
I don't know.
You just come. All right, next group, Christopher. Yeah, Christopher. I like the idea. I can see why you got a lot of attention. In fact, I think Blockstream pitched the kind of idea. That's what I was told like 9 months ago. So I guess that's some validation on both sides. What was the time to fund? Yeah. So you mentioned you had to quickly fund something. Was that just for the demo that you had to quickly fund it on the testnet, or did you have to do that in practice? Like there's some time limit in order to go from one step to the other.
There are a number of different things. This is actually a small...
You want to take this on the mic just really quickly, just 1 minute?
Sorry to make you walk all the way down here.
Where's the mic? Okay. So there's a couple of different things there. We felt like that having a certificate that has a date in it, having the purchase, the transfer of the Bitcoin happening within some reasonable time from that was an additional level of assurance
What time
around.
is that, by the way? Is it like 1 minute time frame?
It's a 10, well, with testnet it's 10 minutes. So probably actually has to be slightly higher than that because of there's a little bit of turnover time. But there's a lot of different things that you get with proof of existence with certificates. I mean, right now, you issue a certificate, and there really isn't a proof of when it was revoked or why it was revoked. There are some protocols for it, but as Mozilla found out, over half of them aren't responding. So, and so much so that Microsoft is now not even reporting to users that's happening. So one of our critical issues is to be able to bring this to the browser, we have to do browser plugins initially. So our focus initially is enterprise, which has a lot more need for server to server and things. And one of the things that when I talked to an IT department, what they wanted to be able to do was revoke the keys of franchises. And that's something that they can't do. So they basically have their own kind of issues of these different people who are doing things in their name, but they don't really have a way to revoke that should they become bad actors. So that was another use for it.
Can you imagine boyfriends and girlfriends breaking out, like revoked your private key access to my loot? Let's see this computer.
Blockchain.
Yeah, what did this be?
How do we know that the ID is true?
Yeah, so for blockchain, how do we know if the ID is true? How do we know that, like, that was kind of an assumption? Like, you're assuming the ID that you're presenting is a valid credential, right? Like, your driver's license, for example. How do we know that's a valid driver's license in this case?
It's not intended to be for things like a driver's license because that requires some sort of authority to give you some sort of privilege. It's more for the identity that you want to present along with your Bitcoin wallet in situations like that. In situations where you would want to talk to someone more about Bitcoin or more about encryption. So it's true as long as you put the information on there and put it on the blockchain.
So last is block notary, I think. Yeah.
Yeah, we had a question about creation time in terms of the document. I just don't remember what the exact question was.
Right, so let's say if I upload a picture or something, do you embed the timestamp when the picture was created, or because you said like if I have to be at court at let's say at some specific point in time, right?
Yeah.
I could take the picture the day before, and then somebody else goes there the next day, for example, and uploads that picture. So the transaction would be at the right time, but I wouldn't have to be there.
So we can prove a document created at the time of submission or before. Okay, so next day we will know it's created the day before. And also we send photo as is with all EXIF data inside the photo, but it's not a proof. No. Also, in the future version we'll add like Merkle tree of additional metadata, and we'll store in blockchain hash of Merkle tree of metadata. So we can record additional data on the phone. For example, if you record video, you can record also like a movement of your camera, like how did you turn your camera, and it can be like additional metadata. Also, you can sign up with social network, it's additional proof. Also, you can ask trusted timestamp server for the time if you want to add additional request. So more data, more proof, but no absolute proof.
We got a question back there.
Just a comment, you could, on the picture you could provide the number of the recent block hash that would be proof that.
Yeah, like it's created now or before. Yeah. So in picture, where's the number of block? Yes. And inside the block was like a,
You could just have a picture of the block that mined 10 minutes ago, then you would prove that it was not taken yesterday, because yesterday you couldn't know the number of the block hash of the day.
yeah, we can use number of block as a timestamp. For sure.
Yeah, great effort.
Does anyone else have any more questions before we wrap that up? No. Okay. So are we gonna? Did you want us to get busy?
A few minutes, just your reflections on the whole evening.
Are we supposed to pick the winner and loser? I'll be honest. Since that's why I'm very frank that way. I actually thought that the very first one, Squirrel, I really like that probably the most, just because I've been talking to a lot of people in finance lately. So get in touch with me. The other one I really liked was the SSL one, SSL revocation. I'm not saying the other ones were bad. I'm just saying those are the two that stood out to me most. So what about you, Fabio? Any thoughts?
Yeah, I'm very impressed with Revoke SSL for 6 weeks. It's pretty solid and.
Well, they had little cheating. The guy invented SSLs. I got it.
Yeah, I really like Block Notary. Think I'm gonna check out their mobile app. And yeah, but everybody did a pretty great job for 6 weeks. Very impressed with what you came up with, and looking forward of where those projects go.
Thanks again, guys. I appreciate it.
Fabio Federici from Coin Analytics, and Tim Swanson of Numbers is his blog. It's also his Twitter handle. Fantastic writer, researcher. Take a look at his work. So let's do another drawing. Lillian, can you help me? So let's offer another class for the Blockchain University, and Anshao. Yay! And let's do another one. Nadia Chuprina. Nadia! Woo! Sure. And we'll do one more. Tess Posner. Just stay in touch and okay. Now let's do our classic group photo.
Everyone get up here.
Listen to Lillian and she'll help us with the group photo. Tall people in the back, women in the front, unless you're tall women, and then whatever.
Don't be shy.
Don't be shy. You were here. Sounds like it was rigged to me. Sponsors.
No?
Solomon. Chris Peel. Ladies of the world.
Oh, but you should get paid for a photo.
Christian Peel. Everybody.
Yeah, just one question. Christian.
See if I can slip in.
Yeah. Wait. Come on in.
Crowd in.
What happened to
Come on. Yvonne, you in the middle. Yeah, of course. Beautiful. Right next to Robert.
Come on in.
Actually, you know what? Someone should kneel. Some people should kneel. Wait, could you stand over here? And we're going to get more people in there.
Come on. Pile in.
Decentralized.
Decentralized. All up front.
Get in here.
Natalie.
Okay, who's going to be next?
Come on, girlfriend. Come on, girlfriend.
Yvonne.
All you guys, your presence did not improve.
Oh, Natalie. Come next to me. Sorry, ready, girls? Okay, we're ready.
I agree.
Yeah.
You can stand on a chair,
I think
Jeff.
we're a little too short there.
Can you get everyone in? 1, 2, 3, jab! Get in here.
Like the old timey photos.
Oh my God. 1, 2, 3, smile.
Double fisting with this guy.
Or to do a panoramic.
My quads are big.
Yeah. Oh my God, the burn from Beta Breeders.
Is that what it is? Beta Breeders? Okay. Did you take your clothes off?
Oh no. But there's a lot of people there.
Yeah.
We're not. And there goes Christian again.
Thanks, Ryan.
I know I got down. I was
Oh,
like,
yeah,
what is that?
Right?
I was like, oh, that's
It's 6 weeks. Yeah, 7 days.